Hello, Math Topics world. Welcome to the first day of home learning. I know you guys are stoked. So I figured probably be best for us to go back and review some things since it's been a couple weeks. And this is kind of the format of how I'm going to do things. I'm going to record these little videos of notes. You'll see in the file on Schoology that there's a PDF of this. If you want to print it out, if you have a printer, you could follow along as I go. It might be helpful. But the first few days is just a review, so I hope you remember it. All right. So we're going to start by simplifying radicals. Remember, the rule here is that you cannot have a perfect square factor under the radical sign. You notice up top I put all the perfect square factors here for you. I mean, not all of them, of course, but there are some that you can reference. We're not really going to use any numbers bigger than these, so this should suffice. So the rule is square root 18. Well, I know that 18 has a factor that's in this list, and that factor is 9. I know that 18 is the same thing as 9 times 2. And because 9 is a perfect square, I could take its square root, and the square root of 9 is 3. So this 9 is going to come out, and when it comes out, it's going to become a 3. And all that's left inside is the 2. That, my friends, is how we simplify a radical expression. So 50, we did this before, so kind of go a little faster, but just comment office hours or let me know if you need help. 50. This is the same thing as 25 times 2. So going up to my list, finding 25 is a factor of 50. Well, 25 is a perfect square, which means I could take its square root. And when you take the square root, it comes out and becomes that root. The square root of 25 is 5, and what's left inside, again, is 2. All right, this last one, 147. You guys, this number is a little harder for you to know all the factors of. It's a bigger number. It's not used frequently. So what you do is you take your calculator and you just start dividing it by some of these perfect square factors until you find one that works. And in doing so, I find that 147 is the same thing as 49 times 3. So now I could take the square root of 49, comes out and becomes a 7, and a 3 is left inside. So, as you guys probably recall, that's how you simplify radicals. All right. Next thing I'll remind you of is how we multiply radical expressions. All right. Now remember I think I told you the story about Susan Garrison, the girl that used to harass me nerdily in math class in college. But anyway, I kind of broke it down easy for you. And what we're going to do is we're going to multiply outside numbers together. So I can multiply the 2 and the 4 together because they're outside the radical symbol. Those are called coefficients. Or I can multiply the radicands together, or the numbers that are inside. So when I multiply these radical expressions, the 2 times 4 gives me 8 on the outside, and the 3 times 5 gives me 15 on the inside. And 15 does not have any perfect square factors other than 1, so it cannot be simplified. So we'll leave it right there. That's in simplest form. All right, now this one. Inside numbers are 3 and 3. Outside number there is the 7. So when I multiply these together, there's only one outside number, the 7. And what's inside is 3 times 3, which is 9. Now this one can break down further because we know that the square root of 9 is just 3. And 7 times 3 is 21. So we multiply root 3 times 7 root 3, that is 21. All right, and over here, we've got our outside number here is 2 and 5. And then for inside numbers, all we have is a little 3 there as a radicand. So 2 times 5 gives me 10, and a 3 is inside. Can't simplify it any further, and that's that. Again, we spent weeks doing this, but I know it's been a while, so you probably forget. But that little reminder hopefully helped. All right, and the last little thing we did with radicands is we divided them. You guys probably remember this. We did this a bunch. This is rationalizing the denominator, and our goal is to get rid of the radical on the bottom. The way we fix these is by multiplying the top and the bottom of this fraction by a square root that will make these denominators perfect squares. So for instance, 3. I can make 3 a perfect square of 9 really easily if I multiply the top and the bottom by 3. That gives me 2 root 3 on top, and then root 3 times root 3 is root 9 on bottom. Then when I rewrite this, I have 2 root 3 on top and the square root of 9, this is the whole reason for this. So I can actually take the square root of 9. Square root of 9 is 3. And that is the goal. Is I do not want to have a radical in the denominator, and I do not any longer, and I'm done. I cannot simplify this any further because 2/3 does not simplify. There we go. All right, this one. Let's see. I want to make 5 a perfect square, and I could do that by multiplying it by 5. So I could get the square root of 25. So I'm going to multiply the top and the bottom by the square root of 5. When I do that, on top, I get 10 square root of 5. On bottom, I get the square root of 25. But the whole point was to use this radical, and I can now, because the square root of 25 is 5. So it's 10 root 5 divided by 5. And this one can simplify further because 10 divided by 5 is 2. So just like with multiplying, you can also divide numbers that are outside the radicals. So you could just divide 10/5 is 2. So you get 2 square root of 5. Perfect. All right, and then the last one here for these rationalizing examples. Now you have a couple choices here. You could multiply the top and the bottom by the square root of 8 to get 64. But if you could always try to make this the smallest perfect square possible, it's going to help. And there's a smaller one you can have, and that is 16. So if I multiply the top and the bottom by the square root of 2, I'm going to get 20 square root of 2 all over the square root of 16. And again, the whole reason for doing this is because I want to be able to take that perfect square, and I can. The square root of 16 is 4. So I get 20 square root of 2 all over 4. And just like in the previous problem, you can actually divide these numbers outside together. 20 divided by 4 gives me 5. So I'm left with 5 square root 2 is my final answer. Those are simplified radical expressions. All right, so moving on, let's take a look at the next part here. And this is your 30. All right, sorry about the glitch there, you guys. I hope that this is working. Let's see, kind of freaking out here. All right, here we go. I think everything's good. Let's hope this keeps working. So now in a 30, 60, 90 triangle, remember this across from the 30-degree angle is called the short leg. And the side across from the 60-degree angle is called the long leg. And then the side across from the 90-degree angle, or the right angle, is called the hypotenuse. Now, if you recall, again, we went through, spent a couple days doing this, so this is just a quick review. But when we did this, everything had to go through the short leg. We're going to call the short leg x. Now, whatever that short leg is, the hypotenuse was double it, so 2x, and the long leg was whatever the short leg was times the square root of 3, so x root 3. And then the next thing we did in class is we made these little maps and said, okay, well, what if you knew, and remember, again, one other important thing to point out is everything's going to go through this short leg, all right? So if you knew the short leg, what would you do to get to the long leg? And what we said we'd do is you'd multiply by 2. And conversely, if you knew I meant to say hypotenuse, I apologize. From the short leg to the hypotenuse, you multiply by 2. Conversely, if you want to go backwards from the hypotenuse to the short leg, you're going to divide by 2. All right, and then to go from the short leg to the long leg, you can see all I did was multiply by the square root of 3. So in my little map, I'm just going to put multiply by the square root of 3. And then, of course, to undo that, to go from the long leg to the short leg, I will then divide by the square root of 3. Great. All right, and then the next thing was the 45, 45, 90 triangle. All right, now in the 45, 45, 90 triangle, there are 2 legs. These legs must be congruent to each other. And then there's the hypotenuse. All right, so we know that in a 45, 45, 90 triangle, the legs are going to be the same because it's isosceles. And the relationship between the legs and the hypotenuse, if you guys remember, is you multiply by the square root of 2. So that will make the hypotenuse x root 2. All right, and we'll draw a little map. So we know, if you know one leg, you know the other leg. These guys are equal to one another. If you know the leg and you want the hypotenuse in a 45, 45, 90 triangle, you multiply by the square root of 2. And if you have the hypotenuse and you want the leg, what we learned in class was that you divide. the square root of 2. All right? And as we go forth and do the problems that we're about to do, the examples, I want you to just pay attention to these reference triangles. You can go back and you can check them out as we go. You know, hopefully you have them drawn on your paper, or you printed this and filled it in, or have your notes that we took in class. But just reference it as we go. All right? So here are some examples. First step in this process is to identify, well, what the heck kind of triangle do I have? All right? Now in this case, I have a 45, 45, 90 triangle. And so we'll go ahead and put a little 45 here in this other angle. And if you look back at that reference triangle, in a 45, 45, 90 triangle, to go from the hypotenuse to a leg, we divide by the square root of 2. So 7 root 2 divided by root 2. The root 2's cancel. You're just left with 7. So x is 7. And then in a 45, 45, 90 triangle, the legs are congruent. So y is also 7. All right. In the next example, example 11, this one, if that's 60 and 90, that leaves 30 degrees here. So we have a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, to go from the short leg, which is what is given to me, that's nice, that's the leg we want to have, you multiply by 2 to get the hypotenuse. So when I do 3 root 2 times 2, I get 6 root 2 for y. And then in a 30, 60, 90 triangle, to go from the short leg to the long leg, we end up multiplying by the square root of 3. So if you do 3 root 2 times root 3, you get 3 root 6 for x. So there's x, there's y. Great, let's do a couple more. All right, again, first thing, identify what kind of triangle we have. This one is a 30, 60, 90 triangle. And now we'll just kind of work through and see what we got. So we know in a 30, 60, 90 triangle, right now we have the hypotenuse. It's across from the right angle. And to go from the hypotenuse to the short leg, we divide by 2. All right, and 6 root 3 divided by 2 is just 3 root 3. So that means this is just 3 root 3. And in a 30, 60, 90 triangle, to go from the short leg to the long leg, you multiply by the square root of 3. So if I do 3 root 3 times the square root of 3, these multiply together, giving me 3 square root of 9. But the square root of 9 is just 3, and 3 times 3 is just 9. So y is 9. All right, in this example, it's also a 30, 60, 90 triangle, and you can tell just by 30 and 90, which leaves 60 here. All right, and here's where we're going to have to rationalize the denominator, because right now we're given the long leg, the leg across from the 60, and we want the short leg. We want the leg across from the 30. So in order to go from the long leg to the short leg, if we go back and look at our little reference triangle, to go from the long leg to the short leg, we divide by the square root of 3. So that's exactly what we're going to do. But when you do this, you got to rationalize your denominator. So I'm going to do my division like a fraction. I'm going to multiply the top and the bottom by the square root of 3, and I get 9 root 3 on top. And root 3 times root 3 is the square root of 9 on bottom. But the square root of 9 is just 3. And then I can simplify this because 9 divided by 3 is 3. So that gives me 3 root 3 for x. And then finally go from the short leg to the hypotenuse in a 30, 60, 90 triangle, we multiply by 2. So 3 root 3 times 2, that's going to give me, the 3 and the 2 multiply to give me 6 root 3. So y is 6 root 3. All right, and just 2 more. All right. Both of these are 45, 45, 90 triangles. So here we go. In a 45, 45, 90 triangle, you're going from the hypotenuse to the leg. And if we go back and take a look, to go from the hypotenuse to the leg, we divide by the square root of 2. So we're just going to do the square root of 6. Divided by the square root of 2. They are both inside, which makes this easy. We just divide them, you get root 3. And because it's